Right now, as you're watching this, the sun is 93 million miles away, and every single thing keeping you alive on this planet depends on it staying exactly where it is. So here's a question worth taking seriously. What if it just wasn't there anymore? Not exploded, not dying, just gone, instantly? What would actually happen, and how long would you have? The answer is stranger than you'd think, because for the first several minutes, you wouldn't notice anything at all. Let's set the scene properly. This isn't going to happen. The sun has roughly 5 billion years of fuel left, and this channel isn't in the business of pretending otherwise. But thought experiments like this one aren't just for fun. They force you to confront something most people never actually think about, just how completely, how totally, life on this planet is hostage to a single star. So let's run the numbers, minute by minute, year by year, and see exactly what breaks and when. The moment the sun disappears, nothing happens. Nothing important. Nothing. Not a flicker, not a dimming, not a single change anywhere on Earth. The sky looks completely normal. The sun still hangs there, bright and warm and yellow, exactly where it's always been. That's because light doesn't travel instantly. It travels at, well, the speed of light, and it takes about 8 minutes and 20 seconds for that light to cross the 93 million miles between the sun and Earth. So for that entire window, you're still looking at sunlight that left the sun before it vanished. You are, quite literally, watching a ghost. Here's where it gets genuinely interesting, and where a 200-year-old scientific argument comes back into play. Isaac Newton believed gravity was instantaneous, that if the sun vanished, Earth would feel it that same instant and go flying off into space immediately, no delay. Albert Einstein disagreed. His general theory of relativity predicted that gravity, just like light, propagates at a fixed speed, the speed of light, and cannot move any faster. For decades, this was just theory. Then, in 2016, the LIGO observatory detected gravitational waves directly for the first time, ripples in space-time from colliding black holes, and confirmed that yes, gravity really does travel at exactly this speed. Einstein was right. Which means, if the sun disappeared, Earth wouldn't just keep seeing sunlight for 8 minutes. It would keep orbiting normally for those same 8 minutes, curving through space exactly as if the sun were still there, because the news that it's gone, carried by gravitational waves, hasn't arrived yet either. Then, at exactly 8 minutes and 20 seconds, everything happens at once. The last photons arrive, and the sky goes dark. Not a sunset, not a gradual fade, just an immediate switch to blackness, broken only by stars. And in that same instant, the gravitational pull holding Earth in orbit simply disappears. With nothing left to curve its path, Earth stops following a circle and starts moving in a straight line at the same speed it was already traveling, about 18 miles per second. Earth becomes what astronomers call a rogue planet, and it will keep traveling in that straight line essentially forever because there's nothing out there to stop it. No sunset that night, no sunrise the next morning, ever again. Now here's a detail that surprises almost everyone, and it's the first real "wait, what?" moment in this story. You might expect everyone starts suffocating within days. That's not what happens. Earth's atmosphere holds an almost incomprehensible amount of oxygen, roughly 1.2 million billion metric tons of it. Photosynthesis stops instantly. Sure, plants can't produce more, but the reserve that's already up there is so massive that, in theory, humans could keep breathing normally for centuries, maybe even close to 1,000 years. Oxygen was never going to be the problem. Temperature was always going to be the problem. And that timeline moves fast. Within the first 24 hours, global temperatures begin dropping by roughly 20 degrees Celsius per day. Within a single week, the average surface temperature worldwide falls below freezing. Within a month, small lakes and ponds are frozen solid. Within a year, the average global temperature has crashed to around minus 73 degrees Celsius, roughly minus 100 degrees Fahrenheit, colder than anything ever recorded on Earth's surface, and that's just the average, not the extreme. You'd think the oceans would freeze solid right along with everything else. They don't. And this is the second real surprise in this story. Water has enormous thermal mass, meaning it holds on to heat far longer than air or land does. As the surface of the ocean freezes, that layer of ice actually acts as insulation, trapping the relatively warmer water underneath and dramatically slowing how fast the depths lose heat. Scientists estimate the deep ocean wouldn't freeze completely solid for hundreds of thousands of years. Somewhere in that frozen world, for an almost unimaginable stretch of time, liquid water is still sitting quietly under the ice, protected by the very cold that destroyed everything above it. So could anyone actually survive this? In theory, yes, but not the way you're picturing, not by bundling up. Survival would mean going underground, into bunkers powered by nuclear reactors or by geothermal energy pulled from the Earth's own internal heat, growing food entirely under artificial light in sealed hydroponic farms, recycling every drop of water and every breath of air in a closed loop indefinitely. It's less surviving a really cold winter and more building a permanent space station just underground instead of in orbit. Iceland, sitting on some of the most active geothermal terrain on the planet, would theoretically have a real advantage here. Most of the world would not. Meanwhile, the rest of the solar system wouldn't experience this evenly at all. Mars, already cold and thin-aired, would become nearly indistinguishable from open space within months. It has almost nothing left to lose. But Jupiter and Saturn tell a completely different story. Those planets actually radiate more heat than they absorb from the sun in the first place, generated by their own internal gravitational compression left over from their formation. They'd barely noticed the sun was gone, at least on any timescale that matters to us. And their icy moons, Europa and Enceladus, worlds with liquid oceans hidden under miles of ice, kept liquid by internal heat rather than sunlight, might remain genuinely habitable for microbial life for billions of years after Earth's surface had gone completely dark and silent. Eventually, Earth itself would settle into a strange kind of equilibrium, cooling for millions of years until it reached a stable temperature around minus 240 degrees Celsius. The point where the faint heat still leaking from Earth's core, generated by the slow radioactive decay of elements deep in the mantle, finally balances out the heat radiating away into space. And that internal heat doesn't just vanish. It keeps going for billions of years. Deep in the ocean, in complete darkness, hydrothermal vents would likely keep releasing that heat and chemical energy, and around them, life that never depended on the sun in the first place. Chemosynthetic organisms feeding on chemistry instead of sunlight could plausibly go right on existing. Life on Earth might not fully end. It would just retreat to the one place it never needed, a star to begin with. So, to answer the original question directly, you would have exactly 8 minutes and 20 seconds of a completely normal-looking sky and a completely normal orbit before any of this began, and then decades, maybe a century or two, before the last humans in the last bunkers ran out of ways to keep going. Not an instant apocalypse. A slow, physically inevitable countdown with a few genuine surprises hidden inside it, the oxygen that outlasts the light, the ocean that outlasts the ice above it, the vents on the ocean floor that might outlast all of us. If you found this kind of thing interesting, this is exactly what this channel does. Real physics taken seriously. Real documented mysteries like the WOW signal or Apollo 10's space music, and thought experiments like this one, grounded in what we actually know rather than what sounds dramatic. Subscribe if you want the next one when it lands. And here's the question I'll leave you with. Knowing you'd have almost a decade before things became truly unlivable on the surface, what would you actually do with that time? Would you spend it trying to survive or trying to say goodbye? Let me know in the comments.